Welcome to another video session on signal analysis. In this video, we will be looking into some worked examples. Signals and systems is a problem-oriented subject, so there'll be a lot of problems. So in the previous videos, we have not solved much problems on Unit 1, so we will be looking more into the problems. So first, let us look into sketching of different signals. So we have to sketch this signal 2 into u of t plus 2 minus 2 into u of t minus 3. We already know what is a unit step function, which is represented as u of t, shown like this, which is equal to 1 for t greater than or equal to 0. It has a constant amplitude of 1 and it starts at 0 and goes on up to infinity. So this is what is u of t, the unit step function. But what we have here, if we can recall this operation here, it is the time shift operation. So here there is a plus sign, so it is an advance in time, and there is a minus sign here. So t minus 3 is a delay in time and t plus 2 is an advance in time. So therefore u of t is a unit step function. So this is the advanced signal, and 2 into u of t means it is multiplied by an amplitude of 2. So therefore u of t has an amplitude of 1, whereas 2 into u of t will have an amplitude of 2, and 2 into u of t plus 2 will have an amplitude of 2, and it will not start at 0, it will start at minus 2. So this is 2 into u of t plus 2. So this is a time advance signal. Next, let us sketch 2 into u of t minus 3. So as we can know that t minus 3 means the signal is delayed, and since it is a minus sign, so the amplitude will be negative amplitude. So instead of a positive 2 amplitude, it will have a negative 2 amplitude. Now this is minus 2 into u of t minus 3, and this is plus 2 into u of t plus 2. So these are the two signals. So if you can see from the time interval 0 to 2, this 2 into u of t plus 2 exists, whereas minus 2 into u of t minus 3 does not exist before plus 3. So it exists after plus 3 only. So therefore all this part in this signal is 0. So when you add both of this signal, so therefore u of 2 into u of t plus 2 is present from the time instant minus 2 up to plus 3 here. Okay, as you can recall from the previous understanding, this is 0. So towards the right, it is all plus 1, plus 2, plus 3. And towards the left, it is minus 1, minus 2, minus 3, and so on. So when we find the sum of these two signals, then the result will be a pulse like this. That means it will have a constant amplitude of 2 units starting from time t equals minus 2 up to time t equals plus 3. What happens at plus 3? At plus 3, there is a step signal starting with an amplitude of minus 2, and that is the minus 2 into u of t minus 3. But at the same instant, you also have this signal 2 into u of t plus 2 at t equals 3. So therefore, at t equals 3, plus 2 amplitude plus minus 2 amplitude, if you add both of this, it will become 0. So therefore, the signal beyond 3 will be 0. And as you can see, before -2, there are no signals. So therefore, you will have the resultant signal starting from -2 up to -3. So this is the sketching of this first signal, 2 into u of t plus 2 minus 2 into u of t minus 3. Now let us take another example. This is a product signal, u of t plus 4 into u of minus t plus 4. So now if you see here, this is a simple signal which is only advanced by minus 4. So that means minus of minus 4 becomes plus 4. Whereas here, so t is in the reflection. So first, let us draw the u of t signal, that is unit step signal, which is having a constant amplitude of 1. Next, if you plot the second signal u of t plus 4, it starts at -4. So therefore, this will be the signal u of t plus 4. Next, if you plot the signal u of minus t plus 4, it starts at plus 4 and goes on up to minus infinity. So this signal, you can simply take it as the signal. So if you take out minus as a common in these two, it will be u of minus of t minus 4. So if you say t minus 4 signal, which has an amplitude of 1, it will start at plus 4 and go on up to infinity towards the right this side. But when we take a minus sign common, so that means it's a reflected sign. So we have to fold this. So therefore, it will be starting from 4 and going up to minus minus infinity. So with a constant amplitude of 1. So therefore, these are the two signals. So we have to multiply them. In the previous example, we have added those two signals. Now in this case, we have to multiply the signals. Now in this region, so that means here is that plus 4, whatever we are seeing here, plus 4, it is somewhere here. So plus 5, plus 6, etc. up to infinity comes this side. So after 4, this signal does not exist, whereas this signal exists. So if you take a product of this in this region, let us say this is plus 4 point. So here the amplitude is plus 1, but here the amplitude is 0. So 1 into 0 will be 0. So the product of these two signal will be 0 for time greater than plus 4. And similarly, for time less than minus 4, this signal u of t plus 4 does not exist, whereas u of minus t plus 4 exists. So therefore, the product of these two will be after or before this time instance, minus 4. So this product will be 0. So therefore, you will get a resultant again like a pulse, which will start from minus 4 and end at plus 4. So this is a product signal. So we have sketched this second signal u of t plus 4 into u of minus t plus 4. Now let us look into the sketching of the ramp signal. So we have a ramp r of t which starts with a slope of 1 and it starts at t equals 0. And there is one more ramp signal which starts at t is equal to plus 1. And there is one more ramp. So there are totally 4 ramp signals. One at t equals 0, one at t equals plus 1, one at t equals plus 3, and one at t equals plus 4. Now, these, if you observe these signals, so this is having a negative slope. This is also having a negative slope because the sign outside for this amplitude is minus, so it will be a negative slope, whereas this is a positive slope and this is a positive slope. So r of t is this signal, and let us draw what is minus r of t minus 1 will be a ramp like this, and minus r of t minus 3 will be another ramp signal with a slope of 1, sorry, slope of minus 1 here, and this slope will be plus 1. See, this is going negative. So this is positive going. That means it's rising positive. This is negative going. So if you see the axis, y-axis, this is positive and this is negative. So therefore, this is the slope here is positive and the slope here is negative. So this is minus r of t minus 1 and this is minus r of t minus 3, and there is one more ramp which will have a positive at t equals 4, and it will continue. So if you say r of t, it will start at t equals 0 and continue up to infinity. R of t minus 1 will start at t equals plus 1 and it will continue up to infinity. So the slope will be constant of 1 here, and here the slope will be constant of minus 1. So that's all. Now we have to add all these signals. Now we have drawn what is r of t, what is minus r of t minus 1, what is minus r of t minus 3, what is plus r of t plus 4. So these are the 4 signals. Now we have to add. Now one point we have to understand here is, so when I have added these two ramps, what happens? So this at this signal starts at t equals 0 and goes on, and it is present even at t equals 1 plus 1. And at t equals plus 1, there is a negative ramp that is starting. So this is a positive ramp with a slope of plus 1, and this is a negative ramp with a slope of minus 1. So the signal, as it traverses, so it has reached here at t equals plus 1, it has reached an amplitude of plus 1, and at t equals plus 1, so there is another slope that is starting. There is another ramp that is starting with a minus 1, slope of minus 1. So plus 1 minus 1 will become 0. So therefore, the signal will not drop to 0, but the slope becomes 0. So that means the signal will continue at this amplitude. So when both the slopes are opposite to each other, then the slope will become negative, the amplitude will not become negative. I mean, the amplitude will not become 0. The slope will become 0, but not the amplitude. If the amplitude has fallen to 0, then the amplitude will be at 0. We will see that. Okay, so the next, at t equals 1, this 0 slope continues with a constant amplitude of 1. Next, at t, this will continue at up to t equals plus 3. So at t equals plus 3, there is a negative slope that starts. So therefore, so this plus 1 minus 1 became 0. So there is no more slope now. At t equals plus 3, there should be a negative slope. So a negative slope starts at t equals plus 3. So this starts and continues. So now the total slope is minus 1 only, because plus 1 minus 1 became 0 here, and now one more new slope has come, so it is minus 1. Now this will continue, but if you observe at t equals plus 4, there is another slope, there's another ramp that starts with a slope of plus 1. So as we know, there's already a slope with of minus 1 started from t equals plus 3. So at t equals 4, both the slopes become equal to 0, and the amplitude has also become equal to 0 here, and this continues. Though the ramps continue up to infinity, but because of the amplitudes, it will become 0. The amplitude will become 0. So this is the signal r of t minus r of t minus 1 minus r of t minus 3 plus r of t minus 4. Let us sketch another signal called the pulse signal, which is represented by pi of t minus 2 by 2 plus pi of 2t minus 3.5. Now, if you see here in this signal, if this is confusing, you can simply split the denominator. So this will be pi of, or the pulse, t by 2 minus 1. All right. And here This is 2t minus 3.5. So therefore, if you observe here, if you can recall from the operations on the signals, so there is shifting as well as scaling operation. And when there is shifting and scaling operation, we know that we have to first perform, according to the precedence rule, we first perform the shifting operation, and then the shifted version, we scale it down and satisfy the two conditions which were previously discussed. Okay, so now this is the signal pi of t, which exists from minus half to plus half. Now we want, first we want to signal, from this we want to signal t minus 1, and then we will scale it down to 0.5 or half into t minus half into t minus 1. So that signal we are going to first draw. So first we have this pi of t minus 1. So this signal, which existed from minus half to plus half, is shifted, and if is shifted by 1 unit. So if you shift, if it is delayed by 1 unit, so this point here will come to here, and the center point will go to 1. So therefore, the center point is here. This is at t equals 1. So we have pi of t minus 1. Next, we have to perform the scaling operation, and you know that when we perform the scaling and a value is 0.5, so when a is less than 1, the signal will get expanded. So here, which existed for 1 time unit, is now 2 time units. So it exists from 1 to 3 by satisfying the condition from the time shift, the shifting and scaling operation. So the next, we first take this pi of t and then perform pi of t minus 3.5. So pi of t minus 3.5 means the 0 point, that is the center point, will get shifted or delayed, and it will go to the 3.5 position. So this is the 3.5. So that 0 position has come to 3.5. It is delayed. Now we have to perform the scaling operation of 2, and you know that 2 is greater than 1. So the signal will get compressed. So after performing the scaling operation, the signal will be this. So this is the result. Now we have got pi of 0.5 t minus 1 and pi of 2t minus 3.5. So these are the two signals, and we have to perform the addition of these two signals. So you can see that this signal pi of 0.5t minus 1 exists from 1 to 3, whereas pi of 2t minus 3.5 exists from 1.5 to 2. So when you add these two, so this, between these two time units, that is 1.5 to 2, these two amplitudes will get added up. So 1 plus 1 will be 2. So therefore, the resultant will be a constant amplitude of 1 starting at t equals plus 1, and this will continue up to 1.5, and between 1.5 to 2 you will have another amplitude of plus 1 get added. So you step up to 2, amplitude will be stepped up to 2, and then at t equals 2, the signal will again fall down to 1 amplitude, and it will continue, and it will end to and fall down to 0 at t equals 3. So this will be the resultant signal. So let us take another signal. We have seen r of t separately. We have seen the unit step signal separately. Now we are taking a product of the ramp signal and the unit step signal. And please recall that the integration of the unit step signal is the ramp signal, or the differentiation of the ramp signal is the unit step signal. So they are all related. Okay, now let us draw this signal. So r of minus t will exist for negative values of t. So that means it will start at 0 and it will exist for negative values of t. R of t exists for positive values of t, whereas r of minus t will exist for negative values of t. So therefore, this will be r of minus t. And u of t plus 2 will start at, so since there is a time advance, so it will start at minus 2. So this will be u of t plus 2. So these are the two signals we have drawn. Now we have to find the product of these two signals. As you can see, the u of t plus 2 exists for the positive values of t. Of course, it starts at minus 2, but whereas r of t exists for negative values of 2 beyond minus 2, and it does not exist for positive values of t, as you can see from here. So when you multiply the product, the one signal exists and the other signal is 0 in some regions. So therefore, the product will be 0 in those regions. So therefore, when you multiply, this is r of t into a constant amplitude of 1 will be r of, r of minus t into amplitude of 1 will be 1 itself. And so the ramp would be 1. The slope will be 1, but at t equals minus 2, the amplitude would have reached 2. So therefore, the signal will be at t equals minus 2, the signal would have reached an amplitude of plus 2 and it will end. So this will be the resultant signal. Now let us draw one more signal. So usually we represented the signals like this. X is equal to x of t is equal to some signals, sum of these signals. So in the previous examples, I have just directly drawn, but this is how is a standard form of representing. So x of t is a signal which comprises of all the sum of these signals. So that is what we are going to draw now. Now you have again the previous case, we saw the multiplication of r of t and u of t, that is the ramp and the unit step signal. Now we will see the addition or subtraction of these signals. Now this is half into r of t. Now you see that the slope is half. So that means as you move in the x and y direction, so the slope will be 1 by 2. Okay, so this is the r of t with a slope of half, and u of t minus 2 will start at t equals plus 2 and it has an amplitude of minus 2. So therefore, it will be negative. So this will be minus 2 into u of t minus 2. And again, at t equals plus 4, there will be a ramp, but it will have a minus and it will be a negative going ramp or a falling ramp, and its slope will be half. So therefore, you have a minus half r of t minus 4. So these are the three signals individually we have drawn. Now we have to add them up. All right. So at t equals 0, this half into r of t exists. So this starts and continues up to t equals 2. At t equals 2, there is another signal, unit step signal that comes, but its amplitude is minus 2. So therefore, now this is continuing with a slope of half. So what will be the amplitude at t equals 2? So the amplitude will be equal to 1. So therefore, at t equals 2, the amplitude is equal to 1. So the ramp would have reached an amplitude of 1, and there is a unit step signal starting, and its value is minus 2. So therefore, here the amplitude is plus 1. Plus 1 minus 2 will be minus 1. So the amplitude will fall down to minus 1. And still the ramp has not become 0 because there is no, the slope has not become 0 because there is no other ramp that started with the negative going. So the ramp still continues. So therefore, again from -1, it is a positive going ramp or a rising ramp. So it will continue up. It will continue up to t equals 4. At t equals 4, there is another ramp that is starting with a slope of -1/2. So therefore, this slope, the first ramp slope, is also +1/2, and this other slope, I mean the other signal, ramp signals slope, is also half, but it is -1/2. So therefore, at t equals 4, both the ramps will become, the slope will become 0. So therefore, the signal will be, the x of t signal will be, the final sketch of the x of t signal will be this one. All right. So next, let us draw another signal. X of t is equal to u of t minus u of t minus t plus u of t minus 2t minus u of t minus 3t plus u of 4, sorry, this is t minus 4t, not 4 minus 4t. This is t minus 4t minus u of t minus 5t plus etc. So this pattern continues. So now we see that there is a simple unit step signal. It is all started by delay. Of course, the amplitude will be changing, plus minus, and so on. Now, first we'll draw what is u of t. So here we have shown what is u of t. Next, at t equals capital T can be any value, and that is constant there. So that, let us say, it is of some fundamental period. So at t equals small t is equal to capital T, there is another unit step signal, u of t minus t, and it is having a negative amplitude of -1. So it will be -1. Next, at 2t, there will be a positive step signal. At 3t, there will be a negative step signal. At 4t, there will be a positive step signal. At 5t, there will be a negative step signal, and so on. So that means plus minus, it will keep alternating and it will continue. So it will come like a periodic signal. Now, if we add all these signals, here, now u of t continues at t equals capital T. So this is amplitude of +1. This amplitude is -1. So +1 -1 will become 0. So this will fall down to 0. And this will continue up to 2t. At 2t, there is a unit step. So again, the amplitude will go positive and it will continue up to 3t. At 3t, there is a negative step of -1. So +1 -1 will again become 0 at 3t and it will continue. And at 4, it will be a plus amplitude, and at 5, +1 -1 will become 0 and it will come down to 0. So it will be like a square signal like this. So 0 to t, there is a pulse between 0 to, t to 2t, the pulse is not present, and 2t to 3t, the pulse is present, and 3t to 4t, it is absent, and so on. So this will be a periodic signal, which is the x of t. How we can simply draw the different types of signals by just adding these elementary signals. That is why they are called as elementary signals. Using these, you can construct more and more signals. That is what we call them as elementary signals. Next, similar to the u of t, we are going to now use the r of t and generate a periodic signal. Okay, so here it is r of t minus 2 into r of t minus 1. So you see that the slope is -2. And here it is +1. Here again it is +1. And here it is -1 at t equals +5. And at t equals +6, the amplitude is +1 and so on. So this pattern, -2, +1, +1, -2, +1, +1, -2, +1, +1. So this pattern will continue. So therefore, now let us draw these individual signals. This is r of t, and -2 into r of t -1 means it's a negative going ramp, and the slope will be -2, and it will start at t is equal to +1, and at t is equal to +2, it's a positive going ramp. So we have shown the individual ramps and continue. So whatever is the plus etc. is what we have shown here. Now we have to add up all these signals. So when we add up these signals, this will become, so this is a positive going ramp with a slope of 1. At t equals 1, there is a negative going ramp with a slope of -2. So this slope of +1 and this slope of -2 will give -1. So it will result in a negative going ramp. -1 means negative going ramp. So here, as we can see, from 0 to 1 time unit, so the amplitude has gone up to 1. All right. So, and if the both the ramp, I mean, if both the ramp signals have the same slope, then the slope will become 0, but not the amplitude, right? So that is what I had mentioned. So therefore, here we can see that the first signal has a slope of 1, the second signal has a slope of -1. So therefore, we get a triangular signal pulse like this between 0 to 2. And at t equals +2, there is another ramp. As you can see from here, between 1 and 2, there is the slope is -1, and at t equals +2, there is another ramp with a slope of +1. So therefore, +1 -1 will become 0. So therefore, between 2 to 4, the signal will be 0. Again, at t equals 4, there is a positive ramp, so the signal will rise. And at t equals 5, there is a -2 slope. So therefore, so +1 -2 will be -1. That means the slope will be -1. So it's a negative going. And at t equals 6, there is a positive going ramp with a slope of +1. So -1 plus 1 will become 0, and this will continue. So you will get a triangular pulse like this. So this is what we have seen so far, how we can sketch the different signals. So the next, we will take more problems on classification of signals. Thank you.